Hi all, here we have 2014 higher level question 9. It is based on the chapter sound from your construction studies book. Part A states using notes and freehand sketches explain any two of the following. So sound absorption, sound reflection and reverberation time. So for the purpose of this, I've went through all three of them. Okay, you're getting 6 marks for any two. So sound absorption, this is the amount of sound absorbed by the surfaces and materials in a room. So hard shiny surfaces are likely to reflect sound rather than absorb. So that means if you're in a room with a lot of hard and shiny surfaces, the sound will be kept in it, it won't be absorbed and go out of the room, so there might be an echo in it. Soft surfaces such as carpets, curtains and finishes absorb the sound. So you can see a diagram below how sound is absorbed by materials, and as it strikes the different materials it will get less and less and less. So the softer material, the less that will get quicker, and the harder and shinier the material, the more likely it is to hold its sound going through. Sound reflection. So sound reacts similar to light in the sense that the angle of reflection is equal to the angle of incidence to a surface. It can be used to alter the acoustics in a room, ensuring even distribution. So that's very important when it comes to the likes of entertainment theatres. You can see the diagram there. You have the instant wave where the sound is coming from. Then you see the wave paths, the reflections, and then the angle of incidence and reflection. Reverberation time. This is the amount of time it takes for sound to decline by 60 decibels. It will vary depending on the size of the room and the items in it. So surfaces that reflect sound will have longer reverberation time than soft surfaces. So hard, shiny surfaces will have longer reverberation time. That means it will hold its sound for longer than the likes of having something with carpets and curtains. You can also see a diagram there showing the sound level and then the reverberation time. So as we said, the reverberation time is how long it takes for it to decrease by 60 decibels. So you can see the vertical arrows there, that is 60 decibels of a sound level. And then you have the reverberation time then when it starts to drop. 9 Part B. A bedroom is located on the first floor of a house, directly above the kitchen, as shown in the sketch. Music from the bedroom can be heard in the adjoining rooms and the kitchen beneath. The bedroom has a standard stud partition and a soft floor on wooden joists, with a plasterboard ceiling beneath. It has been decided to upgrade the existing partition and floor to reduce the transmittance of sound from the bedroom. Using notes and freehand sketches show a revised design detailing that will reduce the transmittance of sound through the floor and the existing stud partition. Specify the materials to be used and give their typical dimensions. So you can see there, the drums are being played in the top bedroom on the left. The kitchen is directly underneath, so we're looking at that floor, and then the bedroom to the right hand side of where the drums are, we're also going to look at that stud partition as well. We have to be careful to focus on both individually as the question asks. You can see it's highlighted in bold and. So for 9B, say it's on the top, so just to introduce the answer, revised design detailing that will reduce the transmittance of sound through the floor and existing stud partition. So just underline both of those so we focus on them. So the first one is sound insulation of the floor. So a floating floor may be placed over the existing joints without being nailed. An absorbent quilt could be placed between the battens and the joists. And sand could also be used to reduce transmittance. So we can see the battens, then you have your absorbent quilt, and then your joists. You also have sand in yellow there. You have plywood on the top and the bottom. It shows the 20mm floating floor, and you're getting 4 marks for your notes and 4 marks for your sketches on this. So again, freehand sketch, neatly drawn, labelled and coloured. The second one is sound insulation of the stud partition. So you have a double stud partition wall with cavity and insulating quilt. So you place an absorbent quilt in the cavity, and that increases the sound insulation of the wall. So the reason that's good is that it's a flexible material and creates an extra layer that the sound has to travel through. In the diagram you can see the studs, you can see the space left in the center, and then there's an absorbent material just put there also. On either side then you can see 2 layers of plasterboards with the joints staggering on it. 4 marks for your notes, 4 marks for your sketches. This question also gives 4 marks for staining materials used. So you can see the example of the plywood there, the sand, the absorbent quilt, the floating floor, and then typical dimensions also gets 4 marks. So in the second diagram you can see the cavity is 200mm. The first diagram you can see the battens are 50 by 50mm, the floating floor 20mm, and the absorbent quilt 25mm. C asks us to explain the sound insulation principles associated with the design details you have shown.